Hello friends, welcome back to my YouTube channel again, Technic Navneet, and this is the very first part of Microsoft Azure Data Fundamentals learning course. And in the first part we are going to cover core data concepts. Earlier we have seen the introduction, and even I have shown you in some other videos how you can appear for this examination at no cost. You can get this examination at no cost. Microsoft will provide you 100% discount voucher if you attend their virtual training days, and how you can do that a step by a step and with some other questionnaires that another video is already posted. So in this video we are starting DP900 learning, and the first part is core data concepts. So before we move further, again friends, it's my hearty request you to kindly subscribe to my channel, hit the like button, share it with your friend, colleagues, and to all who all can get benefited with this cloud computing concepts. And if someone is looking for my DP900 certification, even this is useful for students as well. So let's start. So Microsoft's certified Azure Data Fundamentals. In the introduction video we have seen the course is divided into four parts: core data concepts, identify consideration for relational data, then non-relational data, and analytics workload on Azure, and the weightage of the questions is also mentioned. So in this video we are starting with core data concepts. So since, as per my commitment, I have tried to create this course in very easy terms from very beginning, so that even a person who is listening all these things for very first time, he or she will also be able to catch all the concepts. So I am subdividing this part into two, like basic concepts, core data concepts. So basic concepts are also part of core data concepts. It's not like it's just for your understanding only. Questions will be there from here, and also to move further, these are the few basic things you should be knowing before going to the actual course. So like if you are trying to teach any kid about the multiplication, you must have to teach the countings like 1 2 3. So those kind of things we can say. Without any further delay, let's move to basic concepts first, and in the later half of the video we will cover core data concepts as well in the same video. So first we are starting with the basic concepts. So friends, what is data? You may hearing this term at least for, if you are in IT, you may be listening this for 100 times, 200 times. But what exactly a data? So we call it as a data is coming, data is flowing, we are managing the data, we have a database. So what is data? So data can be defined as a collection of fact such as number, description, observation, which is used in decision making. So if you are storing the data, there should be some reason. If you are storing something, it's not like just we want to store. There might be some organizational decision to be make later by doing several analytics, or maybe it's just mandatory stuff to store for the future reference or to comply with the business and governmental rules. But there should be some reason that can be used in decision making. The decision making can be n number of types, but as I said, data is collection of facts can be anything, number, description. So let's take some example. What does it really mean? Before going to an example, I have added one line to define the data in better way. So data may have a literal meaning, may or may not have a literal meaning. Sorry for typo. So there might be a scenario data is not having a literal meaning and it should have a literal meaning. It's not like it should have a literal meaning. If it is having a literal meaning, that is very good. But in this case, a logical support should be there. So if you're writing something, if you are storing something and you are calling it as a data, while looking into the data, if you are able to understand what it is, that is very good and well. If you are not able to understand, then there should be some logical support. So how actually this make a sense? So for this one, we'll take an example, which cumulative example for both the previous statement. So it's about me. My name is Navneet and I'm from India. So once you read this, there can be a number of Navneet in the India, in north side, west, south, east, but still it's not regarding particularly pointing out to me, but you are able to catch this is something about one person whose name is Navneet and he is from India. So you can see from this one, you are able to define the literal meaning. So is it a data? Yes, it is. Now forget about the above line. My name is Navneet and I'm from India. Tell me about this one. Just think what it is. There is some number, 4-letter word base, then M, 11, 5000, cumulative or individually all these things. Does it make any sense? I think no. It doesn't make any sense. If you write this on a paper and give it to someone, I'm not talking about the previous statement. Just focus on this one. So if I write this on a paper and if I provide it to someone, while looking into this, nothing else, just this one line starting from 5 and ending with this 0, one line, will someone be able to find out any meaning on it? No. So is it a data? Ideally, I cannot say. No one can say. It can be a data, it cannot be. It can data if some kind of logical reasoning supporting it. If no, then it's just a junk. So if there is no literal meaning present to you, you can call it's not a data. But if you are not sure, then yeah, it's not sure. So let's add some literal meaning to it. Navneet insurance detail and some headers, policy, coverage, gender, PLC, product line code, and the premium. So now you can understand there is a logical backing for this line. From looking into this, if you write this whole section on a paper and give it to a random person, even not if he is not aware who is Navneet, but he will be able to say this is the insurance detail of Navneet. Like this number is a policy, base is the coverage for that policy, his gender is male, so it is representing as M. Maybe some kind of product is called PLC, so that line code is 11 and he is paying 5000. So it's incomplete data, like 5000 being paid when? Monthly, quarterly, semi-annually, annually. But even we can derive some understanding from here because there is a logical meaning supporting it. So it is a data. Now with this logical meaning, I hope you are liking the way I am explaining it. It's completely my own way. Let's move further. Types of data. When now we are able to say what is data, we understand what is a data. Data is a fact. It can be numerical, it can be alphanumerical, it can be any letter. It may have a literal meaning, but it may not have a literal meaning, but a logical meaning supporting to it makes it as a data. Then how many types of data? So when we proceed further on this discussion, data can be defined by any many ways. Even if you refer many books from many authors, they are defining it in many way, and still new kind of data and new technologies are being developed. This is not a very old technology, hardly 50 years old. So still several kind of data and all are being developed. It can be changed by other way also, it can be defined by other way, but here since we are referring to course of Microsoft Azure data fundamentals, we will define data as the way Azure is defining. So in this way we can call data has one type as a structured, second semi structured, third unstructured. Yes. So as per the Microsoft Azure, Microsoft is defining data as in three way: a structure, semi-structure, and unstructured. We will discuss on detail for every single one: what is a structure, what is semi, what is unstructured. So before going to the definition and other examples, I am putting an example here. So you can see something, a kind of text is written in the unstructured uh, box, and is some kind of coding language in semi structure, while in a structure there is row and columns that you usually see on Microsoft Excel, the way we create on Microsoft Excel or write on Microsoft Excel. So by looking into that, I believe you have got some idea, but we're going to discuss in detail. So first, structured. So structured are the data. Usually these are the organizational data, like a school, college, insurance company, bankings, healthcares. They are stored in row and column. So data which can be stored in the form of row and column. I don't think there can be more detailed and explanatory way to explain this. So I believe maybe this is not so a standard way, but this is the actual what is the structured data. Yes, a structured data is something which can be stored in row and column basis, the same way as we do on Microsoft Excel. That the same I have written here. And also we call it as, so Microsoft Excel is actually a spreadsheet. A spreadsheet is a software where you have privilege to store or write the data in row and column basis. But in Excel, when you are creating a data, you can create it as your wish. But when to call it as structured data, there should be some rules. So every row is a unique entity, and all rows must have same number of columns. So this, in this example you can see, so if you can see 5 rows here, so every single row is presenting a new entity. So it's the row is all about ID1 and name John. The second is all about ID2 and name is David. It's not like in row number 2 we are storing the details of John. In Excel you can write 5 columns for first, you can write 10 columns for second. So you can do that, but to call it as a structured data, the number of columns should be same. So what if for the user 1 I have just 5 details, and for user 2 I have 10 column details? So cannot be I call it as a structure. There are some ways. We can put NA, we can put null on those blank fields, or maybe something the way it's all up to us. The design and the architecture of storing the data. We, even if it is not a structure, we can make it as a structured. We'll go in very detail next, but here I'm just defining the type. Then let's move to semi-structure. So friends, semi-structure is those kind of data. The data is having a structure, but that cannot be stored in row and column form. Now you ask, why cannot be stored and what is the reason? So as in the previous example itself, I just said one quick thing, like how we can make unstructured data, semi-structured data to a structured data, like putting NA or null or not applicable in the blank field. But the use of semi-structures is coming in from other direction. Let's take an example. You are using a social media account. You are posting, however, it's not a completely like complete exact example, because the data storage for these social medias are different way. They are, most of our social media, the service providers, they are they are developing their own way to store the data. But for the time, assume you are having a social media account, I am also having a social media account. You are posting up new stuff every day while I am posting once in a month. Now, is it a good idea if I have to store that post in a single cell of Excel? Is it a good idea to store in that way where the Navneet, the the only one cell will be occupied? Well, for you there would be n number of cell will be occupied, and even that number is not confirmed. That would be keep increasing over the time. Same goes for, let's say, if you're doing shopping from Amazon, Flipkart, or any other online website. I'm the person who shop from these websites regularly. There are n number of entries for me daily, while let's say some other person is just buying laptop and mobile, preferring to buy the laptop and mobile from those websites. So the entries are very less for them. So in that way, there are new innovations like JavaScript object notation, JSON, key value store, graph data which Facebook uses. We will discuss this on later, like when we will be going with the third part, when we will talk about the non-relational database. Just I'll quickly give you an overview. So JSON is a way, you can see here. Here you can see the student id 1 is having 3 rows, a student id 2 is also having 3 rows, but if some other information is available for a student 1, that can be stored here without making the format of the data. But while a student number 2 can keep only 3 columns, but the columns for a student number 1 can be increased. So this is the basic thing. So now again come back to the previous question that I asked. Can we store semi-structured data to a structured way? Yes, we can, by applying some additional methods. But the thing again, it is created with some other reason. Some example that I gave you regarding the social media and the shopping apps, because it's not feasible, it's not a good idea to store data of all the customers in one structured way where the columns can be increased and must be increased as per the individual's nature. So in that way, this kind of semi-structured data are came in picture, especially JSON. I'm talking about JSON. So again, the data has a structure, just it is not good to store in the structured data. So that is why we are calling it as a semi-structure. Now what is unstructured data then? In a single line, don't fit in above category. Example, video file, audio file, documents. So video file, is it a data? Yes, it is a data. The mp3, if you are storing any mp3 in our phone to listen the song on later, or we are recording some voice or doing some kind of other stuff, then is it a data? Is it? Documents, pdf, word file, is it a data? Of course it is a data. You have a very important stuff written there, you have some good information, some knowledgeable thing, or some related to your maybe academics or something. So whatever present there in that pdf, that is a data. Whole document can be called as a data. But can we store in a structure format? No, because how can we visualize the whole PDF? As let's say it's my certificate, it's my DP900 certificate. How can I store it in a structured way? In a structured format, we can say it's a name, the date when I achieved, what is the certificate number. But the graphics can we see by a structure if we store that in a structured form? No, we cannot. For that, we need that PDF document. So this is a data not following in above categories. Similarly, for semi-structure also, we cannot store video audio to our semi-structured format. Semi-structure is again it's the organizational data. So audio, mp3, documents, all we call it as a unstructured data. So This is the baseline of all this DP900. Since the name itself is saying like data fundamentals, so we will be talking about only with the data concepts and the Azure services for all three: structured, semi-structured and unstructured, how we can store, what all the services, rules, security and all other stuff. Hope I was able to make it like understandable in the way I am explaining. Let's move further. After types of a data, we need to talk about type of a storage. So it's similar like relational databases. First we will go with the relational database. So what is a relational database? Very simple. And second, we have non-relational databases. Then we have unstructured data storage types. So this is the three type of a storage. Let's go with a relational database. So friends, what is relational database? Database who can store a structured data. And what is a structured data? A structured data that we store in row and column format, just like their Excel. So the databases who provide the support and the service to store such data which is in the form of row and column. Majorly it is organizational data. So the service who provide us to store such data are called relational databases. RDBMS, relational database management system. You must have heard this thing many of times. Then before going to non-relational, some examples. So Microsoft SQL Server is a relational database service from Microsoft. Oracle databases, very famous. Then MySQL, IBM DB2. So IBM DB2 is another like relational database management system. MySQL is open source. And Oracle databases. Oracle has several product related to relational database. Like they have keep updating it since very beginning. So these are the major stakeholders in the market of relational database service provider. Next we will see non-relational database. So again, non-relational database, I gave you an example, the data which has a structure but it's not good to store in a relational database, like JSON file. XML also I could just an example. XML is another very good example of non-relational data type. Unstructured, semi-structured data type. Sorry, JSON, XML are the example of semi-structured data. So storing such files, we have MongoDB, Apache Cassandra, Redis, Couchbase, Apache HBase. You may have heard of these services. So this all are the service given like the traditional service provider for storing semi-structured data, and hence we call it is the database which is storing semi-structure. We are calling it is a non-relational database. Now coming to unstructured data storage database. So the data storage which provide us the feasibility to store unstructured data like documents, audio file, video files. So those databases are called unstructured data storage database. So Azure Blob Storage is the best example here. The Azure provide this service, Azure Blob Storage. And blob also like the huge data files in text, that also like we will discuss later like what exactly a blob. But for the time, you can, if you are not aware, you can understand the large text file has containing a huge data. Those kind of things are also comes under unstructured data itself, until we store that in a relational database. If it is in file, then it's an unstructured data. So like from Microsoft Azure, the database service which support to store such data is called Azure Blob Storage. So this was the types of storage. Next we are going to see some we will go through some more basic concepts like database and server. So again, what is database? So database is a organized collection of data, so it can be easily accessed and managed. So again, my friends, you have data, but you need a storage. Like you have, let's say, wheat, but you cannot. How can you store your wheat? Like if you have like 100 kilograms of wheat, so you need some storage. So you need some trunk, some kind of storage facility which can store your grains. So those are called your storage. Here same, if you have a data, you need some place and a proper way that you can, it's not just a storing, but you need to see the data, you need to analyze the data, you have to go through that data over the time. So the storage, organized a storage, not just a storage, but always, or I will call it as a organized collection of data. So that will be called is as database. Now next part, server. Then again, what is server? So this word, I think, which is the one of the most googled stuff regarding cloud computing and internet and this data related thing, like what is server. So my friends, server is nothing, just it is a program. It's programmed to perform some particular task. So is it some device like printer or laptop or mobile? No, it's not a device. Then one of my friends said like, I heard in my college, so that is a server room. So what is there? I saw that so many lights are blinking and some wires are there, big machines are there. So what is that? Is it not a server? Why we are calling it as a server room? So though, so in this example itself, it may have come in your mind if you are not aware with these concepts. So those machines are to support that program. Those are not the server, but the support structure hardware who who is actually supporting the program, which we call it as a server. Then what the meaning of having this such program? What this program do? For this one, I'll take another example. Let's say in one weekend you plan to go to a restaurant. So you visited a restaurant, you went there, you took a table, and then a waiter arrived to you. You placed some order to waiter. Waiter Waiter took your order, went to chef, said like this much of the food and uh, other things the customer is ordering, so kindly prepare and give me so I can serve it. So chef will take that list, accordingly he will prepare, he will give back to waiter, waiter will take that food and will give you, and you will enjoy your food. Now in this example, let's compare it with our own database and the data core concept. So you visited a restaurant. So you opened a database, some kind of query facility from where you want to get some data. And the kitchen where the chef was there, that is the database. So you need some data from the database. So you need the food from the kitchen, but can you directly go to kitchen and take the food in a restaurant? No, you cannot. So what you did, you gave that order to waiter. So you gave your order, you wrote a query on a software, the query facilitator software, and just clicked to run. So once you wrote the query, you placed the order of food, and your order was taken by waiter and conveyed to chef. So the server here is the waiter who is taking your query and going to database and asking the database manager to provide me this much of information. Once the database manager provide that information, he took back the information. The waiter, as the waiter had taken the food and delivered to you so that you can enjoy. So server took that data and then came back to you, gave you in a view in in a graphical manner so that you can visualize. So this is the actual understanding regarding this server. What a server means. So server is again in let's come back to the definition. So server is a program, computer program or device that provides a service to another computer program and its user. So I'm just defining it in a very standard way. So you can ask like why device is written. So sometimes many older legacy service provider they used to provide this program with a device. So you need not to buy a device and program separately. You can have a completely ready stuff at your system, but in cloud like Microsoft Azure you need not to have anything on premise. What does it mean? Like they say, however, this is the main course material of AG900 Azure fundamentals, but the basic of the cloud computer you just have to have the basic and the primary needs like a laptop, machine, internet, some hardware. You just need to have everything. You can place it in Azure, you can place it in cloud, and you can take the service. So next topic we'll discuss some important terms like provisioning. So we have already talked about the database and the data. So what is provisioning then? The provisioning is the act of setting up the database server is called provisioning. So it's not just database server only, but setting up the data. So if you set up a database, you store the data and you don't have a server which can load the data to the database or which can provide you the data when you need to analyze or make some decision. So in that case, if you don't have a server, there is no meaning of having a database. So setting up a database server is called provisioning. So why this term is important? This term is important like instead of saying so hey in this so I got some requirement from a new shop owner, they want to have some database so that they store their customer details and employee details not on manual registers but on computers and databases, and I need to do this. So instead of saying this one, you can say I need to do the provisioning. I need for a new customer. Then let's go for normalization. So normalization and also denormalization. So let's say if if any of the customer need to store 100 kind of details for a single customer, or maybe a college is a storing or a school is a storing the marks and the historical events of every student, and every year a student is moving to new standard like 4th to 5th to 6th, so that the columns may get increased, and if the marks of individual subjects are being stored in separate columns, then they have to define a lot of column, and making it as a very bulky database structure is not a good idea. So instead you can split those. You can split as per the standard 5. There would be one table where the subject marks and the details will be stored for class 5 only, and in that class 5 table you need not to store the name, address and other details. That you can store in just one table, and in just class 5 that will be representing all the students which can be connected with the first table, like I'm talking about the star and snowflake schema that we will going to discuss next in detail. But in that way the data storage would be good. If I need to see the students performance on class 5th, I can simply go to that table only. I need to check on 4th and 6th, I can join the tables, I can take out the data. So this process is called normalization. So we split the data into large number of narrow, well-defined tables. Next, we are going to discuss acid principle. ACID. It's not acid, but we call it normally as acid. So ACID principles are kind of the baseline of defining a database. So we will discuss it, and there might be a chance you may get this such related questions in your DP900 examination as well. So A represent atomicity. So atomicity guarantee that each transaction is treated as single unit, which either succeeds completely or fails completely. So yeah, so what does it represent? So atomicity says, so every single row of a database is a unique entity. Now let's say in some of the column there are some junk value and the value is not provided. So even that case, you cannot just throw that one cell out of database and store the rest. So the columns are defined. The row is defining a single unit. Either all columns for that row will be loaded to database or stored to database, or the whole row will go to junk or fallout or somewhere. So either it will succeed completely or it fails completely. But one row has to come as a single entity, a single unit. And this principle we call it as a atomicity. Second principle is consistency. Ensure that the transactions can only take in the data in the database from one valid state to another. So consistency is again, my friends, very important. So I'll take a couple of example here that will explain this thing very well. So let's say there is a banking system. So you have an account in, let's say, some bank. Your friend is having an account in the same bank, and you need to transfer some amount from your bank account to your friend's bank account. So what you are doing, you made a transaction. I am transferring 10,000 to my friend's account. So bank processes it. They deduct the account from an amount from you and credit in your friend's one. Then what happened on database also, on the database level also, the account the whole new row will be created with you with the updated account balance. Now the consistency says, if it is being credited to some other's account, that must have to be decreased from yours. So this one valid state to another, that consistency has to be maintained if it is defined in the database. So it's not like all the time, like if you are depositing cash at if some person is depositing cash at the bank branch, in that case is it required to deduct from somewhere? No, it's not. So that rules has to be defined, and that rules, the consistency rule has to be maintained. Another example I would say, so let's assume you opted out for one debit card. So when can you take a debit card from a bank? When you have a valid account number in that bank. So same in the database level, if a table is storing the data debit card detail, then in that case the entry cannot be made if the user entry is not present in the account number table. So that also falls under consistency. Next we have isolation. So this is a little tricky, but I'll try to explain in the way that I am doing. So it ensures that the concurrent execution of the transactions leave the database in the same state that would have obtained if the transactions were executed sequentially. So what does it represent? So let's say the whole day transaction in any bank, the transaction of whole day was recorded at one place, recorded first locally, and now you are putting it all to the database. So what if instead of storing it in local and keep updating the database, what would happen? So you are entering the data sequentially one by one. Let's say Navneet has sent some money to Krishna. So the data was deducted, the account balance was deducted from me and credited at him, but now it is not happening. The both transaction is stored separately. Now both transactions are going together at the database at some fixed time. So in that way, in that case, if Krishna's account is being credited, Navneet account must have to be debited. So that is what said here. So even if you are processing multiple data at the same time, or you are processing it in a batch, the final outcome must be equal to if the same transaction were made on sequentially, not at one go. So this is called isolation. Hope I was able to make it explain it well. Next, durability. So durability is one kind of assurance. So your data which is stored in the database should be should be remained stored even a system fail or something happens like power outage or some system got crashed. It doesn't if your system is crashed doesn't mean like your data also got crashed. So your data should be keep stored as in the previous a stage when it was like before the crash. So that's called durability. Cumulatively, this is the four principle called ACID, again sorry, ACID, acid principles, and it's a very important in terms of database. Next topic for our important terms, data ingestion. So what is data ingestion? So again, these are the terminologies of the normal data processing. So that is why it is coming under data core concepts. So I'm like I have chosen this terminologies as part of basic concepts. So data ingestion is nothing but a process of capturing the raw data. So let's say in a store or in a shopping mall, transactions are being happened, the cash are being collected at the counters after providing the billing and all. So there should be some method locally which is storing the raw data. It's not like that data is like streaming on the real time and going to database. So this method of storing or capturing, is not storing but capturing the raw data, is called data ingestion. Also, let's say some on-prem applications has stored the data and you are the one who supposed to load all such data into the database. So what you are doing when you are collecting the raw data, you are doing data ingestion. Then what is data transformation and data processing? So data transformation is just converting the data in a more user friendly way. So let's say the raw data is collected but it's not suitable for querying, or maybe it's not good to let's say if CEO wants to see how many sales were happened. So just giving a raw data of a small single products do not make any sense. So in that case, if you are selling electronics and simultaneously if you are selling clothings and you have stored the data in terms of mobile phone, laptop, fridge and other stuff, but CEO is not is not interested to seeing that. They want how much sales percentage was for the electronics and how much was for apparels. So you can transform the data. So you can accumulate all the sales percentage, sales amount and all, and create a new category in new table for just as a category of apparels or electronics. So what you are actually doing, you are transforming your data in a new way. However, the data is same, just you have transformed to more user friendly. The user friendly here is as per your requirement. And also the data processing also. So data might contain anomalies and should be filtered out. So sometimes it happen when the data is being stored at the first place that gets some anomalies. So junk data maybe if customer is not clear with pronunciating his name correctly, or maybe the salesperson is not able to catch the name, he gives any random name. So those kind of information doesn't make any sense. So that should be filtered out. Either usually when a database like provisioning happens, such rules are defined, like what to do with the junk data. Do we need to correct that and load that again, or those are really junk data, we can store that separately, we will check or something. So that depends on the individual requirement. But filtering out such junk values are also comes under data transformation, data processing. Few more terminologies we will discuss. Data querying. So again, what is data querying, my friends? So data querying is a facility. So data is ingested and transformed and stored. Now you want to see the data, so you want to make query. So you, just a way I gave an example at the time of explaining the server. So you are asking for some food to the waiter. So in the database you are querying, so I need some data, I need to see the sales report of August, I need to see the sales report of last month. So for that, if you want to visit, you want a visual of those stored data, you need to query. Then how you can query? So we have a query structure language, SQL, we call it as SQL also. So that is an also a part of this core concept. We will discuss that in later. But I believe you will be able to say what is data querying. So just doing some task so that you can see the data from that database. Then interrelated to that, what is data visualization? So data visualization is just representing the data in tables in form of row and columns, or maybe in document, so that you can see and understand what does that literally means. So some more point I will discuss here, like access to your data in Azure. So Azure I am giving because again this, so access are also defined with some other way, but here we are restricting ourselves to the Azure concepts and Azure services only. So the access we will discuss how it is provided in Azure. So let's say you have a data and you are storing it in a database, you have completed your provisioning, and now now who can see the data? Like you have stored the data, and any, if everyone has a privilege to enter and mock the data, like there is no meaning of keeping the data if data can be changed by anyone. So the access should be defined. So what kind of access can be granted? So read only access. Read only access means one can see the data. The user to whom, let's say if Navneet is granted read only access, so Navneet will be able to see the data but cannot modify with any existing data, or even I cannot create new data, I cannot store or modify or load some new data as well. I just can see whatever present there. Then second comes like read write access. So read write access means read, first we had a read only, now we have a write access as well. So not just reading, but we are also, if someone is able to modify the existing data, the one who has this privilege, if some information is wrong, so if they have that privilege, so they can enter and modify the existing data. So that kind of access we call it as a read write access. Then the owner privilege, the who is the owner privilege, who get the owner privilege? In most of the cases in big organizations like chief technology officers, they have owner privilege, they are the owner of the data, they can do anything, they can modify, they can delete, they can manage, they can add security, they can remove security, they can add new users, they can remove other users also. However, CTO do not do such task like adding or removing the users. But here what I am trying to point out, like the owner privilege who owns the data, and they must have to get all the features enabled for them. So those are called owner privilege. Then what are the roles in the world of data? So roles means once you take a job related to data, so what kind of task you do. So again, I'll give you example of a shopping mall. So you can see n number of employees are there. Some employees, when you visit there, they are their roles are to just store and manage the racks, and once they see uh, some items are missing, they just go down or their storage and they bring out and put that on shelf so that users can buy. Few persons you can see they are just cleaning up. Some are there as a salesperson to assist you to select or buy the correct which fits in the product which fits as per your need. So you can see employees are different, but their roles are defined. Similarly, in the data world, when we are working on a database, the roles has to be defined. So what kind of data, what kind of roles one can have. And again, as I said earlier, this is also we are defining with the Azure terminology. So first we have Azure Database Administration role. So Azure Data Administration role is the database administration, and it is responsible for the design, implementation, maintenance, and operational aspects on on-premises and cloud-based database solutions built on Azure's data services and SQL Server. So database administration are the one. Let's say the ones that decide to store the data on a database. The database can be on-prem, means in your own premise it is installed some storage devices and servers and all, or you are storing completely it on the cloud to maybe let's say Azure. So the design implementation who all are doing this kind of task, those are having the administration role. So those are not just for the design and implementation, but their role also consists the responsibility of maintenance and operational aspects. That is for Azure Database Administrator role. Next we have Data Engineer role. So who are the data engineer? A data engineer collaborates with the stakeholders to design and implement data related assets that include data ingestion, pipeline, cleanliness, transformation activities, and data stored for analytical workloads. So now you have a database stored. Database administrator is performing the task of maintenance operations. Design and implementation was done earlier, but someone need to perform the pipeline. And what is pipeline? So start from the data collection, that is also called data ingestion. So take the data from and take the raw data and do the data ingestion, transform, do the transformation if required. And however, it's not like a manual task but a programmed automated way only. But someone need to do it on a sequential basis or on a regular fixed timing. So those kind of person are called data engineer role. It means those person are actually doing data, is performing data engineer role. They are doing all these tasks. And then we have a data analyst role. So data analyst is less technical, more business, and also like the testing who all perform, the testers, testing people, quality assurance, quality engineers, all comes under data analyst role. So these are the actually some of the way they are doing the analysis to the reason can be multiple. Analysis to check whether data is correct, meeting the goal of the organization of setting up all this database and all, and also presenting the data to the businesses to get their business decisions. So if some person from the business want to see what was the trend of the some sales report or something, or maybe a bank, a higher management from the bank want to check how much car loan was distributed, how much home loans were distributed, similarly how much store money we collected as part of collection and all. So the person who will take this responsibility to analyze the data and create and report and present it to their asking person. So those roles are called data analyst roles. So next we will discuss about schema, like we have completed our important terms. So it's not like everything. This is what I have collected, and I think these are the required thing you need to know about data concepts. So next we will discuss about the schema. What is the schema? The word itself is a very unique if you are new to the database and all. So schema is a cumulative representation of a database. And before going into more detail, let's hear out some basic other definitions. So primary key. So primary key, what is primary key? So we will discuss schema a bit later. Before that, we are just defining few important points like primary key. So what is primary key? So primary key is a column or columns that contain values that uniquely identifies each row in a table. So now our data is stored in a table, and now we have to identify that the rows are unique. Let's say if it is storing the bank account holder details, and there my friends name, let's say if we go by name, so like let's say if storage there with Navneet, so there can be n number of Navneet. So we cannot say by seeing a data the Navneet which is mentioned at row number, let's say 2, and then is the same person to whom I am referring. Same goes for other details also. But account number, bank is providing me a account number, that account number cannot be same for two person. In that case account number become a primary key. But even this example I just thinking, so it's not a correct example, as sometimes if it is joint account, the account number is same, the person is 2, in that case they provide as a customer ID. So customer ID is a primary key. By looking into, if you are querying or if you are searching for the customer ID, then you are directly pointing it out to that one particular person. So that we call it as a primary key. Then what is foreign key? So in very layman terms, if you are using primary key of one table or one storage to make a reference in other table, so the primary key of first table is the foreign key in the second one. The primary key of the second table, which you are taking the reference from the first, that called as a foreign key. So in our previous example itself of that bank, so there is a table called account number. Their customer ID, account number, name, and other stuff are listed down. Now we are creating a other normalized table. Normalization we just discussed back. So in the normalized table called debit card, we are storing the details, the debit card holders. So instead of again storing name and other details, we can make a reference of the customer ID from the table 1, that for this customer ID, this is the debit card details, and we are not storing name and other details in the other table. So this customer ID was the primary key in the one. Simultaneously, it is a foreign key for table 2, while in table 2 this customer ID can be defined as a primary key and cannot be either, since it's not mandatory like every customer is uh, opting for debit card. So maybe in debit card table we can define some other primary key as well. So this is the relation of the primary key and foreign key. Then we will come back to a star schema, to actual topic schema. There we'll again see what is primary key, foreign key. So I'm just giving an kind of picture here. So some of the way, if you see, if you can visualize, it looks like a star. So that is why we are calling it as a star. And in the same example, there is a central table, cells, where we are storing time key, item key, branch key, location key, dollar, units, and on the sides of it we are creating 4 new tables, which are the tables for item, location, branch and time. So these tables, who are the branches of the main table, are called dimensions, and the main table who are stored in the middle are called fact table. So fact table are supported by dimension table, in a way we can say. So here it is storing some basic details. It is taking as an item key. So here primary key can be like time key or item key, but one column item key is taken as a primary key. So item key become foreign key here in the fact table, sales table, and regarding that item key further informations are stored here. Similarly, location key is also a foreign key, and in the location dimension table, those such information are stored here related to the location key. Same goes for disk2 as well. So overall, this kind of a storage are called a star schema. So when we really come to real world, my friends, storing in a single table is just a theoretical term. So we cannot, like, even if it is a single store of a single apparel or some one product selling organization, if they are creating some kind of database, there also it's impossible to just store the data in one table. So so the data used to be stored in this way only. So after a star schema, then we have snowflake schema. So some dimension table in snowflake are normalized. The normalization is splits up the data into additional tables. So again, I'll explain with this example. So you can say this, as we saw in the previous example, the central table is called the fact table, this one, and all of these are called the dimension table. However, the dimension table is again have another dimension. So for this one particular dimension table, this this table item called is a fact. However, it itself is a dimension, but for dimension supplier, sorry, this item table is itself is a dimension table, but again it has a sub table called dimension, means this table is normalized further, like the bigger rows are splitted into narrow uh, columns and data is normalized. So this is a dimension table of a dimension already dimension, which sorry, this supplier is a dimension table for the item table, and item table itself is a dimension with the sales table. So so the item is dimension for fact, sorry, again I'll say item is a dimension table for sales and fact table for supplier. So if dimensions, now coming back to first line, if dimensions are further normalized, so that is called snowflake schema. And uh, I was just talking about, like, in the real world, even a star schema is just a theoretical things, my friends. So data used to be stored only on a snowflake schema only. So maybe some small organization or the one who are just starting with storing the data on the database management system, they are opting for a star schema. But if you think about any organization, if you just imagine, even storing in a single table is like impossible already, I said. Even storing in a star schema doesn't make any sense, like it cannot serve the purpose completely of having a relational database management system. So the actually, what wherever you see a database management system, the data usually are stored in the snowflake schema. So this was the schema discussion. I hope I was able to explain. So next we'll go with Azure. So as of now we were discussing about the core data concepts, or maybe to say the basics of the data concepts. So then, since we are opting for Azure certification, we are learning data concepts related to Azure. Now the question arrives, what is Azure? Azure is a kind of server, is it a database or something? No. So Azure in terms of business, it's a cloud computing service, is a business unit of Microsoft, just like Windows. So Windows is operating system business unit of the Microsoft. So similarly, so cloud computing services are cumulatively, they call it as Azure. And what it is for? It is for building, testing, deploying, and managing applications and other services through Microsoft managed data centers. And these data centers, the storing this data in these data centers are called cloud. So what is meaning of Microsoft managed data centers? We'll discuss little more on it. Before that, so this is the link, but this link is, I think it's typo, like this link is now changed with portal.azure.com. I missed to update here, sorry for that. The correct link I will post in the chat box, sorry, in the description box. And if you learn about more, this is the link that will also be present in the like description box. From there you can navigate and go and see the learning materials provided by the Microsoft. So yeah, so what about these data centers? We were talking about that. So when you store your data on cloud, what does it mean? Are we storing it in a sky, or are we where this like what happened? Let's assume like we are 30 years back. So if you want to have a RDBMS, you have to buy some storage device, big storage device, some devices who can store and programmed and can work as a server, and then you need to have a connect like the uh, system which can uh, work intermediately, just like a internet. It's just providing you a connection, and maybe intranet. No, internet is not required if you are doing it on premise. And then to maintenance where you need electricity, and since there are multiple machines working there, some chips and all, so you need a very high air conditioning system and all. So you know where your data is being stored. So those systems used to be present in the on premises, whoever is opting for any database management system. Now when we say cloud computing, you don't need to have those. You can subscribe to those services or those things as a service. Like you can subscribe to Microsoft Azure RDBMS SQL Server. You can have a VM, or even if you are not able to catch these terms, we'll discuss on later. But for the time, if you whatever you were doing on with this on premises hardware, you can directly have it on cloud, and you can use that using internet. But even if it is in cloud, that need to be stored somewhere. So Microsoft has created so many data centers like this across the globe. Like you can see, this is the one of the picture of Microsoft data center, and I think it is from Dublin, I believe. So this is the map provided by Azure, like wherever a data center is present. In India, 3 data centers are there. In like China, Japan, several in the Europe, several in the USA. In South America, we have two in Brazil. Then Africa, two locations are there. The data centers, South Africa, North South Africa, West. So UAE, then in Middle East also. So they have tried covering all across the globe, okay, by creating these data centers. So what is it the mean, like if I am residing in India, my data will be stored in India? No, absolutely no. It's all up to you where you want to store your data. So when you do all this kind of like cloud computing setup, you whenever, like if you are taking any single service, any RDBMS service or anything, it the whole decision will lies on you. So you can, if even if you are in India, you want to store your data in central US, you can store data with there also. But like that that has several other aspects also. Like I don't want to call it directly like you can, yes you can, but that decision has to come after uh, checking multiple things. So let's say if your base customer base is in India, your data is in central US, so there will be some latency means the actual delay in serving your request. So if you place something and you see a long time, sometimes you may see like if you clicked on something on online service or somewhere, you see a long time there is a wheel rotating and you can see the loading. So what is happening in the background, actually that request is being made and your required data or required information is being pulled. So for everything there would be some latency, so that has to be considered while setting up those things. But I'm just saying how you can do that. So in the previous page, like I have mentioned this link incorrectly, so kindly uh, check on portal.azure.com. I'll quickly show. So this is the Microsoft portal of the Azure services. You can have a free account here. Even while doing your certification, you will create a Microsoft account. With that also you can have this one. You can go, you can some play around. If you are not subscribing anything, it's fine. You can go, you can check the services, you can see the apps, what kind of data they have, categories they have made, what kind of categories they have AI, machine learning, everything. And even if you want to subscribe, you have always you always can do that. And even you see, get 200 free credit towards Microsoft Azure Enterprise services plus 12 month of popular free service. So if you start with your free trial, if you click on a start, you can have $200 in your account as a welcome gift. But you cannot get that money to your bank account or something. You can use that money to buy the subscription, setting up the database and doing other things. So I'm just showing the landing page of the Azure. So again the correct URL is portal.azure.com. Let's go back to our original subject material. So here I am closing the first part, the half of the first part that I called as basic concepts. So again coming back to the course material, there are four segments. The first is describe core data concepts, which weights around 25 to 30% of the questions in the examination. And I had subdivided it into two parts, basic concepts and core data concepts. So we just have completed basic concepts, and we need to go with the core data concepts. So again, my friends, this is the way I have curated this course. So again, I want do not expect like Microsoft, the way I have curated that course, it's from Microsoft. So actually I made a list of the topics which are being covered here, and I just segregated those into two so that I can make it explainable. I can make it very easy to explain, especially to whom who are very new to this organization, new to this system. They are listening these terms for first time, or they are just entering, they are students. Even if you are a professional but not aware with the cloud computing, the data concepts, or you are very new to have this certification. So in that way I segregated the course between two, basic concepts and data concepts. So we just have completed the basic concepts. Now let's continue with the core data concepts. So the first part in the core data concepts, we'll call it as a data workload. So friends, now we know what is data, type of a storage, how storage works, how to do provisioning, what is normalization. We have already covered that. Now we will talk about the data workload. So now we have everything, but how we can do that? So actually data workload, how data is being processed. So there is two way. One is a batch data, one is a streaming data. So I have talked about this one, but not particularly taken this name. So batch data, it's like data first are stored in format of CSV or TSV, tab separated file, JSON or XML, or maybe Apache Parquet. That is a more efficient than CSV. Like in Apache Parquet format, you can have more data by less occupying spaces, and then blob files, another database also. So batch maybe at one place the data is stored first in any of this listed method, and then it went for a processing on a fixed time. Let's say for every day the daily transactions are being stored locally, and every 5 p.m. in the evening that is taken for upload it into the database and do the further transformation and the load process. So that is the one way, that's called the batch data. And then second, we have the streaming data, when the data processings are happening on the real time. So once a data is created, immediately that will be sent to get stored to the database. So best example, before going on this example, I would take example of Netflix and YouTube videos. So what is happening, it's not like you are placing an order and they are asking you to just wait for 30 minutes, we will curate this thing and we will give you the your required video that you want to see. It's not happen, right? So once you just click on the video, data start playing to you. So actually the data is streaming to you from their storage. That is what happening. So that is for video. But event hub or IoT hub, so these are things are very kind of in fashion right now. You can incorporate IoT with your daily appliances. You can ask your fridge to, hey, do something for me, like have some ice when I'll come back to home. So if you say something and it now just think you want ice before you reach the home with your fridge. Now I'm taking a very daily life example, and its data is stored in somewhere which will process in batch in evening time, and you are reaching home by 2 p.m. Is it serving the purpose? No. So the data has to be stored at the same time when you are placing that order. You are like asking that to do to maybe any IoT hub means the system which is related to artificial intelligence and machine learning, the services which are provided by Microsoft Azure. We have we'll talk about this in detail also, but I'm just giving an example of the streaming data. Streaming data is not just a video audio from Netflix and YouTube, but these are kind of examples are also for about the streaming data. Then blob storages, Apache Kafka is the leading service provider of this section. Then even with the organizational data batch processing, let's say if data transactions are huge in the whole day, if data is supposed to be stored for like million records, so running in batch is not a feasible stuff. So it's better to stream it live, or there are third way, but we call it as a batch only, when the batch used to run for 5 minutes only. Sometimes you see you create an account and you get a message, just wait for 10 minutes, this service will be active for you after 10 minutes. So what is happening in the background, your data was stored, but the batch processing time is just a 10 minute. So that's the third part, but as a definition we will call it as a two, batch and streaming. Then next topic we are going to discuss characteristics of the relational data. So since we have discussed all of things earlier, Now we are going to discuss it in detail. So what are the characteristics? Obviously tables. So tables where we store the data, and we are only talking about relational data right now. For non-relational and unstructured, we would have a separate section, separate video for that. To store the relational data, we store it in the tables. When we do the query, the like row and column representation that comes to us to visualize the data, that calls views. Primary key we just talked about. Primary key is the uniquely identify the row column which uniquely identifies a row. Then to make a relationship between two columns, we use foreign key, parent child, like the fact dimension uh, concept. Then integrity and referential integrity, we have discussed about ACID principle. So database integrity is also important. The one example I'll quickly give, same as previous, like some entry in a banking database management system, entry in debit card table can only be done if the user has a entry in the account number or savings account number table. So those kind of integrity are the characteristics of the relational data. Then we'll talk about the data analytics. So friend, what is data analytics? Before going into that, I would ask, like, why data analytics? The problem of too much data. So if you have 100 records, by looking into Excel or somewhere in the views on database querying facility, you can somehow visualize what is happening. What about the data is like 1000 in rows and 100 columns, 1000 rows, maybe 10,000 of rows with 1000 of columns. However, just not a good idea to have that. We have a system of normalization. In that case, we should normalize the tables into narrow columned tables. But what about in those cases? Does it make any sense uh, to, let's say, non-technical person or the person who are from the business? So we need some data analytics, data visualization, those rows into some way so it can be explained and understand better. So data analytics, however, I started telling about the data visualization, which is our next topic, which is appearing lower section here. But a data analytics, like doing the analysis or doing uh, some kind of analysis here over the data to find out the trend or some create some relation or to take out some uh, something which can create some impact on the business and all. So that we call it as data analytics. So we will have a separate section of data analytics later. Next we will talk about the data visualization. So friends, what is data visualization? So data visualization I just talked. So like representing huge number of data in some format, some way, so you can identify what is actually happening, the trend you can identify when something is going up, when something is going down. And if you want to check the exact count, you will have that privilege. You can either see from here or you can check by going back to your database. But as a trend or something, you can directly visualize from here. Same goes maybe something map, let's say how much sales happened at which place. So you can have this kind of Manhattan long buildings kind of thing, and you can identify, at least you can say like this place the sales was higher, this some places, nearby places, the sales was higher in comparison to others but lower than the main one. So creating this kind of more analytic and user friendly representation, we call it as a data visualization. And Microsoft has a separate segment of that, power apps. So power apps are having four kind of applications, but the major aspect is the Power BI. Power BI is a like free tool from where you can ingest the data, your raw data, and you can create such matrices. So will and also like PL900 is a fundamental certification over that course. I will down the line I will create videos for that as well. And if you want to do PL900, you can do that certification as well. And even the way you can have a free voucher for DP900, you can also have the free voucher for PL900. For that you have to visit my other video regarding how to get free certification for 5 Microsoft certification, and that all for no cost. For let's move back to our original content of this video. So next, so since we have talked about the data analytics, so now we have 5 types of analytics. So friends, this is the one of the most important topic, and if you are able to understand this correctly, you don't even need you don't even need to do a kind of uh, learn again or revise this. If you understand the concept, you don't even need to revise. You can go in the examination. If related questions will come, you will be able to answer. And this is a kind of common topic between DP900 certification and AI 900 certification. So I'll also create a video for AI 900 maybe within a month. There you will see it is a major topic for that certification, but here also at least one or two question you must be getting, and in AI 900 there must be 5 questions related to this one. However, in AI 900, that is more the same concepts, but more regarding to artificial intelligence. So first, analytics techniques. So we Microsoft is defining 5 analytics techniques: descriptive, diagnostics, predictive, prescriptive, and cognitive. So this is the 5 type of analytics. We'll discuss one by one again. So what is descriptive analytics? So friend, descriptive analytics is like what happened. And when I say what happened, that means if I am doing an analysis over the data, I am seeing the data and I am trying to find out what exactly happened. How much sales have, when I say like what happened, then what is today's sales, like service appointment booked, what is the net margin, like what is the different net margin. When I say, it means like the difference between like from previous day and all, like, but not doing any comparison, just we are seeing, we just we are writing what actually happened with the data, like not only just today's sale. If you are doing in a bank, like you are doing descriptive analytic related to loans for a period of 1 year, and you are just writing what happened. My bank gave 1 million rupees as a car loan, 2 million as a home loan. We received 1.5 million from car loan, but received only zero point 0.5 from the home loan. So those kind of analytics, when we are creating those, we call it as a descriptive analytics. Then next we have a diagnostic analytics. Here we are talking about why did it happen. When we go to into details, we drill down into the data and check what is the sales change per location. So in descriptive we are checking what was the today's sales, but in diagnostic, if we observe that the sales were drastically higher or it was very low, then what is the change per location? Is it happening at everywhere or just happening at one place? So why it is happening? So the reason can be anything, like customer who had their problem solved in first visit, so they are coming, like they are let's say the traffic. If customers came and their problem was solved with the first visit itself, and if in other location if it is happening after 2. So actually if you are charging at one time only, and if you are like serving that customer twice with the same charge, so actually in a way you are decreasing your sales. So those kind of tricks, like this is the last two line written in your screen, is like why happen. So just a kind of example reason in case of sales or some services, uh, sales report is decreasing in that case maybe. So maybe like this is happening, customer for visited one time and their problem solved with other location. With the first visit no solution was given or adequate solution was not given, so they are coming back, so traffic is more. But since we have already charged, we cannot charge twice, so overall sales was decreased. Third, we do as a predictive analytics. So predictive analytics are the way of doing the analysis, creating the report from the data, like what will likely happen in the future. So if we are checking the data for a longer time, and we are able to identify the trends, and if we are able to get the logic between that, if we have done the diagnostic analytics and we know why it is happened, so corrective measures like we can check and we can predict. So for example, if in India October, September, November, October, November are the festive season, and the car sales and the sale of the gold or ornaments are higher, and it is happening every year. So seeing the data, we can predict that at that time this year also the sales would be higher, and we can be prepared with like pre-orders or something. So this kind of things, analytics, we call it as a predictive analytics. And one example like the weather prediction. So weather prediction is not always like the satellite images or something. So we can say like the December, when this December will arrive, the temperature will be down. And Azure portal also, like Azure portal have this predictive analytics thing integrated with them. They predict your bill at the end of the month, like what would be the expected bill as per your services and all. And they are it not just the subscribed, like if your data is keep growing, like, and you are like over the period you are going with the new services, you are opting new services regularly based on the trend, the data, and your behavior, they predict your bills. So those we call it as a predictive. And before proceeding to the next, which is the prescriptive, I would say I would like to say one thing. All this analytics, like five types of analytics, is all being made with the data, not like someone is visiting the market and asking the people or something. So we are doing this analytics only with the existing available data. So we have just talked about descriptive, diagnostic, predictive. Next we have prescriptive analytics. So prescriptive analytics is like what should I do? So some kind of suggestion, same as a Google map navigation. So once you place something like I want to go to this place, you put it on the Google map. So Google map is not just show you the actual direction, but it shows also the possible shortcuts. Or maybe like if you go by this path, you will have like more travel time, because some like roads are not good, maybe on some kind of data. Again I would say like the data, the inputs are the data, or maybe the reviews of the people, or maybe if they are able to identify the traffic is heavy at some places, so they provide some prescriptive analytics to you. So that kind of analytics we call it as a prescriptive. Next we have the cognitive, the last one. So cognitive is a combined of all four, and the best part here is it in it uh, it's related to AI ML, artificial intelligence and machine learning. The example is like self-driving car. So self-driving car, they are taking the pictures, they are doing several algorithms are working in the background, they are doing several analytics, they are doing predictive, prescriptive, diagnostic, everything they are doing, and come up with a decision what should to do next. So the like uh, the catch here, or you can while attempting the examination, if you have to distinguish the question, the use of images, audio, this kind of things, if you see, that comes under cognitive, means the part of the data must be including, or maybe the analytics method must be including some, at least some of the things as AI ML, artificial intelligence and machine learning, that we call it as a cognitive analytics. So questions usually you get the examination related this one, and how the questions will come, like very simple. They will give you some scenario and you have to identify which uh, kind of analytics it is. So again, I just gave you an example. If you see any use of images and all, that images kind of things only artificial intelligence can identify and proceed, so those comes under analytics. Similarly, if you see some example, like what will have, so data is present like the sales report, and I need to project what will happen at the same time next year, what kind of data what kind of analytics we need to do, that we will call it as a predictive analytics. So now friends, we are heading towards the last discussion of this very first part, and I just realized that this video was so lengthy, but I believe the next video won't be that longer, because the next part is regarding the relational database, and the references and the examples in this video that we have taken, that was most on relational part. So just repeating the same part doesn't make any sense, and your time is also precious. So next video will not be that longer. Let's complete this video by the last topic, last discussion. So ELT and ETL. So you may have heard these terms, ELT, ETL. So what it represent? Is it two different thing, or is it completely mutually exclusive, or is the same? So we will discuss on that. Before, let's first check what these three letters represent. So E stand for extraction, and extraction is how you get the data from the outside. And when I say outside, outside means it can be anything, the on-prem applications which all are storing the data locally on maybe some desktop software which has an embedded database, and it is being stored there in the form of CSV or Parquet or in other some other formats. And one new term just you may have heard, that is embedded database. So embedded database nothing, just a storage facility for a particular software that store the data locally in that software only, and not being connected with any storage system or DBMS system. So collecting those data from the on-prem point of sale system, on-prem applications are part of extraction, and it is not just limited to that. Now let's say you are a middleware application, you are working in a middleware application, or you are going to create, or you are in a middleware or any downstream, and you need to data from some other system. In that case also, even your upstream or your source system is a dedicated DBMS system, then also getting that data from them, asking the data from them, is a part of extraction. Then the next word we have is, next letter we have is L, and it is representing loading. So loading is the action of getting that data into a database. So you got the data as part of extraction. Now you need to include all those in your system. So actually what you are doing, you are loading the data. You extracted the data, now you need to load the data in your system. So that part comes under L, and then T representing transformations. So what is transformation then? So transformation is just a little changing the representation of the data. However, the data will be same, but using the transformation, you can modify them, or the storage system, not the storage system, but the data. So let's say your source system is storing the data in 2 columns for a name. So your source system is storing the name of the person, but into 2 columns, first name and last name. But your end user can be anyone, whether these are the customers or maybe some business user of your application. They want to see the full name when they are asking for the data. So you need to make some transformation, you need to concat them. Even there can be n number of representation of the same thing. So those kind of things comes under transformation, and this is a very basic example. Transformations can be anything, like the source collection of the data and the final visualization are completely different. So just I'll give you a complex example. So let's say you are a bank user, you have a bank account, and you are doing n number of things daily, right? Like you have a debit card, you go to ATM, you just check the balance. Through UPI you are just checking the balance, you are logging into the net banking but not performing any transactions. But all these activities are being stored at somewhere, because bank need to make a history, so that if some fraud, if you are reporting any fraud or any anomaly on the account, they can go back and trace those things. But that is really needed to see on daily basis? No. So they make some changes, those are being stored at somewhere, but some transformers are excluding them. They are storing in those activities on some database, but the transformers are excluding them when you are seeing it on your net banking. Net banking must be like in the most of cases nowadays it is coming from some cloud service provider, but those also comes under transformation. So whether it's ELT or ETL, the meaning of E, L and T would be same. Now what is this? So ETL is an overall process. It's like a legacy system of the management of database. So first you extract the data, then transform, I'm talking about ETL, then you load the data, and I'm talking about ETL. So you extract the data, you transform the data and load as per in your database, and before loading you do the transformation as per your requirement. But Azure is moreover preferring to do ELT. Their architecture supports ELT most, and it's not like you cannot do ETL with the Azure services. You can modify the architecture. You have the full privilege how you want to process it, but this is what their existing services and system are designed in like that prefer ELT. So here we quickly see. So in ETL you are extracting, in this diagram the representation is given like that. You are extracting the data from the source, you are doing the transformation, and then you are loading. While in ELT extraction was done first, obviously extraction has to be done first, then it is loaded, and while it is being loaded, transformation is also in the progress. So in some of the way this is like nowadays more preferable. However, ETL is the traditional way. If you take an example of Informatica Power Center, so that is one of the most famous ETL tool that can extract the data from multiple sources like SQL Server, IBM DB2. Then they transform internally by making the cache, and then once the transformation done, that is first stored in form of cache in the Power Center itself, and then that get loaded to the target database. But in ELT extraction, the load and transformations are happening simultaneously In some cases, the transform data may get loaded to the same tables, or maybe there would be some other table for the transform data, and in a way you have privilege to see both transformed and non-transformed data. So then the data processing, what kind of data processing these services, these processes support: batch processing, stream processing. So again, is it just a confusing term? Since this is a data processing, so it has to be supporting both batch and stream. The batch and stream is two method of loading data process. Like in batch, first data is stored in chunks, and then over some time, or like we have discussed earlier, so the batch, like in the CSV, Parquet and all, that get loaded to database. And in stream, the whenever a data is created, it get processed immediately. So both supports batch streaming and stream processing, batch processing, stream processing. So like you may get some questions in your examination also. So ELT supports batch processing, stream processing, none of these, both of them, this kind of, or maybe a checkbox where you have to select batch and stream both. Let's move. So this is the representation of how batch processing and stream processing can be done. So this is a represented graphical representation over the Azure services. So first we are checking the batch process. So for in the batch processes, data is coming from the data source, those are getting stored in data storages, and then batch processing are happening using Hive, Pig, Spark, USQL, and then again the analytical data store where the transform data are stored, and then it goes further for analytics and reporting. While in batch processes, the data can come from the data source or from data storage both, and it is going to ingestion using event hubs, IoT hubs, Kafka. So these are the services, Azure services, which is to support the real-time processing. So data can come like a single row at a time or multiple row at a time also. So then it goes for stream processing, and then we have Spark streaming, Storm, stream analytics. So these Azure services which do the further processing of the real-time data, and then that got stored in the analytical data store, and then further it goes for analytics and reporting like using Power BI or some further tool. So this is like the two representation which is supporting this statement that the ELT and ETL can be done with both batch and stream. And you can see there is orchestration strip here. So orchestration is nothing, just a programmed way of doing all these activities one by one, a single program which is performing one after one the activities. So friends, this was the last topic, as I said earlier. So we are closing this session here, the part 1 of Microsoft Data Fundamentals course. So kindly hit the like button, subscribe to my channel if you have not subscribed earlier, share it with your friends, and we will meet again on our next video, that is the part 2, relational database. Thank you.